So there are a lot of requirements and there are a lot of rules, and this comes through practice and process, and it'll get easier and easier the more we do it, but it's going to look pretty intimidating here at the beginning. But let's go through the requirements for a covalent compound, a Lewis structure, to be valid. First of all, we have to show all of the valence electrons. For all of the elements, all of the atoms in a compound, we have to show all of their valence electrons. Usually, all of the electrons are paired. More often than not, electrons are going to be in pairs. You will rarely have a single electron. Usually, all atoms need 8 valence electrons. The main exception that we're going to see is hydrogen. Hydrogen only needs 2 valence electrons. Sometimes we can have what are called multiple bonds in order for everything to reach 8. So sometimes you'll have what's called a double bond or a triple bond, where instead of sharing 2 electrons, 2 atoms are going to share 4 or 6 electrons by having multiple bonds. And then finally, each bond always has 2 electrons. So whenever you draw a bond, you're indicating that there are 2 electrons being shared between those 2 atoms. So each bond counts as 2 electrons. Okay, so let's go through the rules. We're going to go through these step by step, and then we're going to apply all of the rules to different examples. The very first thing that you're going to want to do is count all of your valence electrons. So we'll go through, based on the periodic table, how many valence electrons does each atom have, and look at the total. So that's the pooling all of the valence electrons together. The next thing you're going to do is you're going to figure out the central and the terminal atoms. So what's going to be in the middle of your molecule and what's going to be on the outside. So central is going to be in the middle, terminal will be on the outside. Hydrogen atoms are always, always, always terminal. You will never have a hydrogen in the middle of your molecule. Carbon atoms are always your central atoms. In the molecules that we're going to be drawing, your carbon will always be in the center. So carbons are always central. Once you kind of arrange them, then you're going to start drawing your bonds. So you're going to arrange them first, then you'll draw your bonds, you'll draw those connections, and you're going to start with just single bonds. So you'll connect your terminal to your central atoms with single bonds. You'll subtract those single bonds from your total number of valence electrons, and then using your extra valence electrons you have, you'll start completing the octets. You'll start with the outside atoms, and you're going to add electrons until each atom has 8. So once all of your terminal atoms have 8 valence electrons, including the electrons in the bonds, then if you still have extra electrons, you'll go to your central atom and add electrons until your central atom has 8 valence electrons. Now at this point, you might have hit 0. You have no electrons to put in place. All of your terminal atoms have 8 valence electrons. Your central atom has 8 valence electrons. Some of those might be in bonds, but you've reached the end of your electrons. That's fine. If you are out of electrons and your central atom does not have 8 valence electrons, that's when you need to pull in additional bonds. So instead of an outside atom having a pair of electrons, that pair of electrons will become a bond with the central atom. We're going to go through examples that cover every single one of these rules, so we'll look at how they're all applied when we actually draw Lewis structures. So our first example is nitrogen triiodide, Ni3. So our first step is to figure out what the total number of valence electrons we have to work with. So nitrogen has 5, and we have 3 iodines, and each iodine has 7 valence electrons. So these numbers came from where they are in the periodic table. Nitrogen has 5, each iodine has 7, and we have 3 of them total. It means we have a total of 26 electrons that we need to place. So that's step 1. Step 2 is to figure out our central and terminal atoms. Our central atom is usually going to be our single atom. So in this case, it's going to be the nitrogen. So that's going to be our central. Our terminal will be our I's, and we'll arrange those around. Now, once we've arranged them, we're going to connect each with single bonds. So we're just going to draw single lines to represent the bonds. Now, each of these bonds represents 2 electrons, so we've already used 6 of our total electrons. So I'm going to keep a running total over here on the side. I started with 26. I've used 6, and so now I'm down to 20. Now that I have them connected, I'm going to start with their outside atoms and add electron pairs until each have 8. So this one already has 2 from the bond. So there's 4, there's 6, there's 8. So I've used 6 more electrons. I've already counted for these guys. I've used 6 more, so I'm going to subtract 6 from over here. That leaves me with 14. I'm going to do the same with this guy. So it already has 2. There's 4. There's 6. There's 8. So I've used 6 more electrons. Remember, I've already counted the ones in the pairs. That leaves me with 8. So I'm going to start over here, do the same thing. There's 2 in the bond. There's 4. There's 6. There's 8. I've used 6 more valence electrons. So I have 2 more electrons that need a home. Now, each of my terminal atoms has 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. My nitrogen, though, just has 2, 4, 6. So it needs 2 more electrons. So I draw a pair there. And those are my last 2 electrons. Now I've used all my electrons, and each atom has 8 electrons. We have CH2F2. Our first task is to count valence electrons. So carbon is going to have 4. We have 2 hydrogens. Each hydrogen has 1 valence electron. We have 2 fluorines. Each fluorine has 7 valence electrons. So we have 14 plus 2 plus 4 gets us to a total of 20 electrons to work with. So once we've counted up our total valence electrons, we're going to find our central atom. Our central atom is going to be carbon. So we're going to draw carbon in the middle. And we're going to arrange our other atoms around it. It doesn't really matter what order they're in. We're not really going to be too concerned about that. So now that I've arranged my terminal atoms around my central atom, I'm going to draw my bonds. So now I have single bonds. So I started with 20 electrons. I've used 2, 4, 6, 8 of them because each bond has 2 electrons. So I subtract 8 from my total, and I'm left with 12. So now I'm going to take my electrons and I'm going to start filling the octets. Now remember, the hydrogens only need those 2 electrons. I'm not going to add any more electrons to the hydrogens. Instead, I'm going to add electrons to my fluorines. Now fluorine has 2, 4, 6, 8. I've used 6 more electrons, so I'm going to subtract that from my running total. This fluorine still needs 8, so I'm going to add 6 more. So now it has 2 in the bond, 4, 6, 8. I've added 6 more. Now I'm out of electrons, so let's double check and make sure I've met all my requirements. Each of my fluorines have 8. We've checked that already. The hydrogens are good because they only need 2, so they're good with just the bonds. You'll never have extra electrons on hydrogens. And my carbon is also good. It has 2, 4, 6, 8 valence electrons. They just all happen to be in bonds. That's okay.